So every class was slightly different where I had you leave off, but I believe I left it off with some of you guys do intrusive, some of you do extrusive. Yep, some of you are agreeing with me. So let's hear what you had to say. So remember, we were doing igneous rocks on Friday. We had already learned from our reference tables, how do igneous rocks form? That's where I want to start. How do igneous rocks form?
They form by weathering erosion.
No.
Weathering. Solve it.
Okay, yeah. So remember how I do want you guys, before you answer a question, I want you to shut your mouth. Inhale through your nose. Nose. Let that oxygen get to your brain while you think of the answer before you just shout anything out. Okay? So let's try this again. My question is, how do igneous rocks form? Shut your mouth. Shut your mouth. Inhale through your nose. Let the oxygen get to your brain. Now, Carter, how do igneous rocks form?
Solidification.
Right, that's when magma solidifies into an igneous rock. Let's put this right at the very top margin of your paper in case you forget this. Igneous rocks form by the melting and solidification. Oop, I just squeeze that in there. Melting and solidification of magma. You can't forget that. Well, okay, you can forget that as long as you know how to read the reference table. And remember, when you're reading the reference table, take your time and you find the rock. So if you guys forgot how to do this, you find the rock I'm talking about, and to figure out how it formed, what do we do to figure out how it formed?
You rush the wing.
No. How do we figure out how it formed?
You follow the arrows. Backwards.
Backwards. Figure out how one of them formed, you follow the arrows backwards. Igneous rock forms when any rock gets melted into magma and then solidifies. You will need to be able to use your reference table to do that. Then on Friday, we started learning more details about igneous rocks. We learned there's two types, intrusive and extrusive igneous rocks. We then read through the reading and you should have found where each one forms, how they formed, which really means how they cool, and then what they look like, their physical properties, and then an example of each. I forgot how I divided you guys up. Who did what?
This after that.
That's what we did, that extrusive and intrusive. All right, let's start with intrusive then, people on this side of the room. What is the environment of formation, meaning where do intrusive igneous rocks form?
Magma rocks.
No, okay, that doesn't say where. So here's a Here's a really good teaching moment.
Dang it.
You have to be careful to answer the question that's asked, not the one you think I'm asking. So if I say where it forms, magma is not an answer. So Kat, I'm sorry, let me try again. Where do igneous rocks form? Or intrusive igneous rocks form?
I said that it came from magma.
Okay, good-ish. Did anybody put something slightly different? Okay, so here's the thing. I feel like I asked you guys not to write on page 13, but maybe I didn't because it looks like all of you did.
No, you didn't.
Okay, so we got to make sure those notes that are going in page 13 are 100% correct. So you have it okay. I just want to simplify that because again, you went with the whole story. I just want to know where. And to keep it simple, they cool inside.
Cool.
Or they cool inside Earth. So if you have more than that, does anybody want an eraser or some white out to change that?
Why do you say cool when it's supposed to be where it comes from?
So I did. So where does it come from? I'm telling you that they cool, and I didn't write that,
Insider.
but where do they cool? Inside Earth. So do you know what magma is? Let's start there.
Mhm.
What is it? No, it's not in there. What is magma? Because you keep saying magma. It's melted rock.
Yeah, it's nothing.
So melted rock, what do we know about melted rock?
It was like liquid,
And why is it liquid?
it's melted,
And why did it melt?
because it got heated up.
Heated up, it got hot, so hot that it melted. So that's why, just like if you melt chocolate, how does it solidify? What's it have to do? Cools. So that's why I keep saying cools, because that hot magma has to cool. No.
Yeah.
All right. So does everybody have that? So I know like Kat, you had way more than that. Can you circle or change or erase and make sure you put just, I really need to emphasize intrusive is inside Earth. Carter, do you have that where it says inside Earth?
Yeah, it says inside Earth.
Perfect. Now for the cooling. So how is it formed? We already established the magma has to cool. For intrusive,
Deep inside the crust, Earth's crust.
hey, Carter, you did it again, first of all. I need you to stop shouting out answers. And then you have to stop and think, did I answer the question? It says how, and you said deep inside the Earth, crust. Okay, so that's where, that's what you should have said before.
Dude, what?
So you need to know the difference. You have to read the question that's there and answer that question. So let's try this again, not Carter this time. There's other people in this group. How about you, Cassidy? Did you get how does it cool? Where would you write? You wrote something. I saw you have something. Okay, cools down in the Earth's crust. So again, you guys got that confused? Caitlin? That's what we need. That's all we need there, is that it cools slowly. So it cools slowly where? Inside Earth's surface or inside the Earth. All right, you inside Earth crust people, because it cools slowly inside of Earth, what is it gonna look like?
It's gonna look
What are the physical properties from the reading? Yeah, Caitlin? Large crystals.
I had that one right.
Good. Large, you might have even said visible crystals, but large crystals is good enough. So hopefully I made this clear that the rest of you should be copying this one down. Okay. And there was one example given in the reading. Yeah, granite.
Granite. I had that one too.
Good. And then you had the right answers for both of them. You just flipped them. Because again, you have to answer the questions that's being asked.
Ooh.
So let's talk about this large crystal thing. Here is granite. Do you guys know what granite is?
The mineral.
No, it's not.
It's the rock.
You did it again. Can
It
you-
looks like a mineral.
Okay, but I'm not gonna ask you again. You need to keep your mouth shut. Think. Then if I ask you to shout it out, then you can shout out. But I really need you to think before you speak. So here's the rock granite. Why am I saying it's not a mineral, it's a rock? So, okay, some rocks aren't minerals, and what did you add to that, Keith? This is made of minerals. In fact, and I know you guys can't see it great on the screen, so I'm gonna hold it up and you guys can see it better. You can see big, giant pink minerals. You can probably see some big white minerals and some black minerals. So this isn't a mineral. This is a rock that's made out of minerals. You guys might be familiar with granite because, what's that look like? I think you said it. What'd you say? Countertop. It's a granite countertop right there. So you can see what it looks like in real life. So if you found this rock out while you were on a walk, it would look more like that, just an average rock. But when you cut and polish it, that's where you get the countertops from. So you can see why granite's made for countertops. It's pretty. It has nice colors. It's shiny. People like it in their house. The other thing with granite is depending on which minerals show up more in that particular piece, you might end up with lots of different colors. We're gonna talk about granite a little more in the next couple of days. So these, see each one of these black chunks, each one of these pink chunks, each white chunk, those are each crystals. And they're mineral crystals, yes. And you can see how big they are. I mean, I can hold it up and you can see that big black chunk? That's one crystal. So that's a pretty big crystal if you can see it from the back of the room. Do you not see it?
I see it.
That black, any of the black chunks, you can see it.
Okay.
It's a mineral, it's got big crystals. That's intrusive. Any easy ways to remember this? In, yep. Circle the in intrusive. I covered up the N, yes. And that goes with the inside earth. Now, why do you think it cools slowly when it's inside earth? Okay, one is that the inside of the earth is hot. And even if it's not where it's exactly hot, all the other layers that are on top of it,
Yeah, it's all covered up.
it's all, yeah,
You
it's
can't
covered.
see it, so it's gonna cool slowly.
Right, well, when you are all covered up in your bed,
You're warm.
you're nice and warm
Cozy.
and cozy. Oh man, I wanna go back to bed.
Damn,
So
why
warm
does-
and cozy, it takes you a while to cool down if you are inside lots of layers of blankets. So being inside the earth, the layers of the earth act like a blanket to keep it as warm as long as possible.
If you think about it, we could just have a nap class.
A nap class, I'd love a nap class. So again, they cool slowly because they're inside. Now, because they're cooling slowly, it gives the rock time to grow these big, beautiful crystals. That's how it works. Now we'll go to the extrusives. That was you guys?
I'm over there.
Extrusive. Now here, don't fall for the same trick. Where do they form? At the Earth's surface. So on Earth's surface. Carter said on the outside. That's another way of thinking about it. So if you want to say they cool on the outside. And again, this one's not quite as easy to remember, but the extrusive, the EX, what does that kind of hint you towards? Exit. And when you exit the building or you exit the room, you're going on the outside. So that's again, a hint to help you. So how do they form? Because they're on the outside, how do they form? They cool, not you, fast.
It's just the opposite of everything.
It is kind of the opposite. And because they cool fast, what will they look like?
Small.
I want you to add small or no. Small or no crystals. And when you said that, make sure you're thinking of the actual crystals on the inside. We're not talking about the rock itself. Okay, so not like this one in my hand is a big one. We're talking about the individual crystals on the inside being big or small. And basically anything you can see is considered a big crystal. If you have to like squint to see it, like I think of, you guys know what glitter is? Like one piece of glitter.
Yeah.
Okay, one piece of glitter, that would be small. Anything bigger than that would be considered a big crystal. There were several examples in the reading. I heard you say one of them. Obsidian. Anybody else see any others? I couldn't hear you. What? Yeah, I believe it's pronounced pumice, but I knew exactly what you said meant when you said pumice. Pumice. And there was actually one more.
Probably, basalt.
Yeah, basalt. So let me show you what some of these examples. So obsidian, which yes, is on Minecraft. That's that one. What do you see there? See any crystals?
Yeah.
No.
No, there are no individual crystals. There's not a single one in there that like stands out almost like a piece of glitter. Yes, the whole thing is kind of shiny, but that's because this is considered volcanic glass. Here's another one. I'm not sure if I'm gonna be able to get this one to show up. Okay, so I can pass this around, but you guys can kind of see up here. again,
That's all.
there, can you see the little black specks?
Yeah.
Those kind of look like little pieces of glitter. If you could see it up close, they really, really do look like one individual piece of glitter. That is what's called small crystals. So this one cooled so fast that the crystals did not have time to grow. All right. The last thing for igneous rocks today. Not, so we kind of made a chart that showed the differences. But did you catch any similarities between intrusive igneous rocks and extrusive igneous rocks? Keep it simple.
I didn't get to it.
They're both what kind of rocks?
Igneous.
They're both igneous
That's crazy.
rocks. Now, again, what does that mean to be an igneous rock?
So. Formed by solidification.
Okay, so they're both formed by the,
Solidification or solidification?
so to be perfectly honest, I don't think, what do you think, Mrs. Wilkinson? Would you call it solidification or solidification? Solidification. Okay, that's a third. Oh, you're math anyway, right? Or are you ELA? Okay, that's what I thought. That's why I asked. Okay, so we got a resident ELA teacher here to help us. She says it's solidification. But if you say solidification, I'd know what you're talking about. I'd know what he's getting at though. So formed by the melting
Of rock.
and solidification, yep. Of rocks.
Of rock.
Yeah, melting and solidification of rocks. So they both form the exact same way. So what makes them different then from what we just
One's
did?
inside the
One
other,
inside
one's
there, the
outside.
one's outside there.
So inside Earth, outside Earth. When we say outside, please don't think I'm talking about
Surface.
space.
Surface.
I mean surface,
Like where we are right now.
right where we are right now.
Yeah, do we?
You guys are weird. What's another huge difference between them, not just where they
Slowly
form?
cools fast.
Okay, intrusive cools slowly. These ones, oops, I should have said cools slowly, cools fast.
What boy, do we?
What else is really different about them?
Probably.
Large crystal, small, and no crystals.
Large crystals,
Smaller, no.
small or no.
Double air.
Enough, guys. Believe it or not, you're not that funny. Those are basically all the differences. So what do you think? Are they more similar or more different?
More different.
More similar.
What?
More different when I say more different.
Because there's more difference.
There are more differences? That's kind of a lame way of explaining it.
Alright, whatever.
One is the crystals.
Okay, so you think they're more different or more similar? More different, because their crystals are way different. Where they formed are way different. But you say they're more similar. They're both still igneous rocks. I don't think there's a good answer, as long as you can defend it with a better explanation, then there's a bigger list.
Targeted. I don't understand.
No, that's not it. It's because you're the one who's always told you.
Fine, I'll be quiet so no one else talks either.
Oh, well, then I'll just start calling on people.
Yeah?
All right, so we have what, about 20 minutes left?
Yeah, 21.
All right, 21 minutes left. Here's what I want to do. Closing this packet to the cover for right now.
Oh, dang, I thought you were going to say the rest of the class.
So you have a quiz tomorrow. You have a quiz on Wednesday. Okay,
And tomorrow.
tomorrow we are going to play a game, a review game to for minerals. It's going to be called Mineral Guess Who. You guys know the game Guess Who? Okay. Does anybody not know the game Guess Who? All right, we'll introduce it tomorrow. But it's gonna work the same way as the actual game that you play. And then you have a quiz on Friday. No, you don't. I said Wednesday. Sorry, I spoke before I thought.
Exactly.
Or I was just really hoping tomorrow was Friday.
Do everything.
Anyway. So to get ready for that quiz, I think the only thing that we're missing is some practice doing Regents questions.
No.
No, so if you think you don't need the practice, that's great. You're gonna fly through these 18 questions that we're about to do right now with no problem whatsoever. But if you do think you need some review, that's what we're going to be doing for the next 20 minutes, are these 18 questions. I want you to pretend this is an open notes quiz right now. Meaning, treat it like it's a quiz, so truly try, you have 20 minutes to do it. But look up things you're stuck on. And speaking of looking up, don't forget your reference table. You'll have the reference table for tomorrow's game, and you'll have the reference table for the quiz on Wednesday. So definitely use your reference table today and your notes today. You will not be able to use your notes on Wednesday, but you can definitely use the reference table on Wednesday. So I want you to spend today trying these. And the good news is there's 2 of us here to help you if you're stuck. But yeah, this is all we're doing for the rest of the period. If you don't finish though, it's homework. So there's 18 questions in about 20 minutes, so you should either finish or get really close to finishing.
Come on, Miss Reds.
What page?
Sure,
Yes.
What page
it's
are
in the
we
packet I just handed out. So again, here's the 18. If you're watching the video, you can just pause this and read the questions on
Go.
What are we doing?
on the screen.
What?
Pretend it's a quiz.
Do we need our reference table?